Hey everyone, we're going to find the limit of these two problems. Alright, so for the first one, we notice when we plug in the 3 here, we're going to get 0. And there's no such thing as ln of 0, because our graph, remember, looks like this. So it's not in our domain. 0 is not in our domain. So a way around that is we're going to let t equal x squared minus 9. Now, if we let t equal x squared minus 9, then we need to also determine that if x approaches 3 from the right, then if we're letting t be this, then t is going to approach 0 from the right, because I'm changing this. If you plug in 3 into that, you get 0. So doing that, we can now write this as limit as x approaches 3 from the right of ln of x squared minus 9, and rewrite this as limit as t approaches 0 from the right of ln of t. And if you notice that we already have it written down right here, and that's going to equal negative infinity. And again, looking at our graph here, as we approach from the right, our limit is going to negative infinity. So that's why that rule works. So that's the answer for that. Now, the second one is this one. So the first thing you do when you have this is we're going to write this as a single logarithm. So we're going to write this as limit, and this should be actually x. So let's change this to x. As x approaches infinity of ln of, I'm going to condense it, 2 plus x divided by 1 plus x. Now, what you need to know for limits in an infinity is that if you have the limit as x approaches infinity of 1 divided by x, that equals 0. So you use that a lot. This equals 0. And the reason that's true is as this number gets bigger and bigger, so if I put, a bunch of zeros here, as this number gets bigger and bigger, this is going to get closer and closer to 0. So the trick is to write this as divide each of these terms by x. I'm going to rewrite this as the limit as x approaches infinity of ln, and I'm going to divide each of these terms by x. So you're going to get 2 divided by x plus x divided by x divided by 1 divided by x plus x divided by x. All right, so that reduces to the limit as x approaches infinity of ln of 2x plus 1 and 1 divided by x plus 1. So when you plug in your infinity, these two are going to go to 0. So what you're left with is the limit as x approaches infinity of 1 divided by 1, which equals ln of 1, and ln of 1 is equal to 0, number 4. So this equals 0. And that's because if you do the inverse, sum a to the 0 equals 1. So if you're doing the inverse, that means ln of 0 equals, ln of 1 equals 0, sorry. Okay, so that's just a quick review on that. Thank you. Have a nice day. Bye-bye.